And in the previous video I was trying to explain the process of deviation of light. Now when you have an equilateral triangle, each angle is 60 degrees, right? And then light hits the triangle at one end, and the angle between the normal and that angle is called the angle of incidence. The angle between the normal and that ray of light that hits the triangle is called the angle of incidence. And then the angle between the normal and the opposite side, and then the ray that comes outward, that is the resultant ray, is called the angle of emergence. Now you can notice that this is a demonstration of refraction, and then we are going to solve for an equation that we'll use to actually satisfy some solutions. Now, first of all, let's look at this. This is an angle of incidence. Now, and this is angle of refraction. Yeah, because this is between the normal and the refracted ray. So this is angle of refraction. Let's call it R1. Then we also call this one. Let's join them here. Then we call this one at the other end R2. Now, if we trace the path which the light is supposed to follow, and then we calculate the deviation between that path and the actual path the light follows, that deviation is called the D. It's called D. That's called angle of deviation. Now we are going to make use of this angle of deviation, and in recent times, physicists plotted some values, and when you plot the value of the deviation against the incidence, it will give you a U curve. Now this U curve is a characteristic U curve, and I will explain it now. What that means is that for any particular angle for any particular deviation, there are two possible angle of incidences. So, and that advocates the fact that light is rectilinearly propagated, and that means that light can reverse its direction and still follow the same path. So when you reverse the direction of light, it follows the same path because light obeys rectilinear propagation. That means at any particular deviation of the angle, you have an angle 1, an angle 2. You can call that I1 and I2. So ideally, one of these is called the angle of incidence, and the other is called the angle of reflection. Sorry, angle of emergence. So one of these is called angle of incidence, one of these is called angle of emergence, because when light follows the backward process, it still follows the same path. So, but if it follows backwards, the I will become the E and the E will become the I. So, but you can notice that at a particular point, when there's the minimum deviation, the point that I and E coincide at the point below this. So this point, this bottom of this U curve is called the minimum deviation, and this minimum deviation, let's denote it as small letter d. This minimum deviation occurs at when there are two equal angle of incidences. So that means whether you trace the path from this direction or you trace from this direction, your angle of incidence will still be equal. So now that means that your angle of incidence will be equal to your angle of emergence. So now let's use that to solve some equations. Now this angle of deviation, let's call it D. We can say D is equal to, now this angle here, let's call this A, let's call this B, let's call this C, let's call this D, let's avoid the letter D, let's call this E, let's call this F, this point, G. Yes, we are good with that. Now this angle, the angle of incidence is equal to the angle, let's call this one, yeah, let's call this H. The angle HEG, the angle HED, D is equal to this angle here, or this angle, because exterior angle of a triangle is equal to the opposite, sum of the opposite exterior angles. So that means this exterior angle is equal to sum of the interior angles, right? So that means this angle D is equal to this angle HEF plus the angle HFA. But now let's look at the fact that angle HEG will be equal to the incidence angle. And why is that? Because it is vertically opposite. So, and if that is the case, then angle HFG also should also be equal to the emergence angle. That will be E. That's also because of vertically opposite angles. So that means we can now sufficiently say that this HEF is, you can arrive at HEF by subtracting FEG from HEG. That means, So FEG is R. That will be, so HEF will become your I minus your R1, and then HFE will become your E minus your R2. So, and we said earlier that deviation is HEF plus HFE, right? So that means deviation will be equal to I minus R1 plus E minus R2. So when we collect lectures, we have I plus E. D is equal to I plus E minus open bracket R1 plus R2. So we've arrived at this equation for the deviation. Now, but now we're not just looking for the deviation, but we're looking for the minimum deviation. Now for this minimum deviation, the angle I will be equal to the angle E. So that means D will become small letter D. Let's call it minimum deviation. Small letter D. D will become 2I minus R1 plus R2. But still, looking at this again, when the angle of when this I is equal to this one, let's clean this in and call it I2. So that means this becomes what? This becomes I minus R1. This becomes I minus R2. So I minus R2. And so as a result of that, this R1 will also be equal to R2 when the incidence angles and the emergence angle are equal. So the refracted angles will also be equal because light propagated on opposite direction is rectilinear. So that means R1 will be equal to R2. So your D will exactly become 2I minus 2R. That will be 2I minus R. So now let's move on to another derivation. Let's see what else we can derive from this. So moving on, we have this angle to be 60, right? So, and this angle here, angle AE, this is a number, right? So this angle is 90 degrees, and this is a number, so this angle was also 90 degrees. So that means you can also sufficiently claim that this quadrilateral, sum of angles in a quadrilateral is 360 degrees, right? So in this quadrilateral, let's bring that A quadrilateral A E F G. So what if angle A is 60 degrees and angle E is 90, so that means the remaining two will sum up to 180 because the total angle is 360. So that means this angle will be 180 minus 60, that's 120 degrees. So that means this angle G is also 120 degrees from our derivation. So next, that means we know that our R1 is equal to our R2, right? But our derivative, our D, so now let's forget the fact that this is 60. Let's just call it A. Let's just call it A and clean this up. Let's call this A. So if this is A, now let's make some other derivations. Now this is a number, right? So the angle between the number and the surface is 90 degrees. Then the remaining angle here will be 90 degrees. That means this angle AEF, angle AEF will be equal to what? 90 minus R1, and then angle AFE will also be equal to 90 minus R2. But we know that angle AEF plus angle AFE plus angle A on top, yeah, this angle A at the apex will sum up to 180. Why? Because sum of angles in a triangle is 180. So that means A, let's call it A plus 90 minus R1 plus 90 minus R2 is equal to 180. That means A is equal to A plus 180 minus R1 minus R2 is equal to 180. So let's cancel 180 on both sides. That means A is equal to R1. Moving R1 to the other side, R1 plus R2. That is our A. And this A is also known as a refractive angle of the medium or of the triangle. Now moving on, we notice that A is R1 plus R2. But in our equation we have this is equal to I plus E is equal to 2I minus R1 plus R2. So that means D will be equal to what? 2I minus R1 plus R2. But A is R1 plus R2. So that means D will be equal to 2I. Let's substitute A is R1 plus R2. That's 2I minus A. So moving A to the other side, we have A plus D is equal to 2I. That means dividing 2 by 2, we have I is equal to A plus D over 2. So this is the minimum deviation. This is the formula for calculating the this angle. So A is equal to I is equal to A plus D over 2, and this actually applies for every angle of deviation, not just the minimum deviation. Then next, let's move on to the fact that since at minimum deviation, R1 is equal to R2, because as I mentioned earlier, light propagates in two opposite directions and it is rectilinear. So that means their path will be the same. That means when the I is equals to E, that means the angle of incidence is equal to the angle of emergence. That is when minimum deviation occurs, as this graph indicates. And at that point, the incidence angle is equal to your emergence angle. They are both equal to I, and then your refracted angle at both ends are equal. That means R1 is equal to R2. That's because of the minimum deviation. Then we have that A is equal to R1 plus R2. That's 2R. That means when we divide both sides by 2, R becomes A over 2. So we've successfully found an expression for I incidence angle and R refracted angle. So now we can now use Snell's law to complete the whole equation, saying that sine of the angle of incidence over sine of the angle of refraction is equal to a constant, which is the refractive index. Now sine of angle of incidence, I is A plus D over 2. This is our equation 1. And let's have equation 2. That means sine of A plus D over 2 over the sine of A over 2 is our refractive index. So, and that is the derivation of a very important formula in physics used in calculating. So thank you for